Hi everyone. I'm just filming sort of a short summary here of everything that we've talked about so far with ionic compounds, because I was getting some comments that there's a bit of confusion, especially when we mix all of them together and try to figure out how to name them or write the chemical formula for some of these examples. So I've put together this little flow chart that I hope helps if you are struggling with it. As always, feel free to email me questions that you have. So we'll start with naming ionic compounds. So this is when you have the formula and you're trying to name the compound. So the first question you're always going to want to ask yourself is, how many elements are there? If there's two, you'll go one way. If there's more than two, then automatically you have a polyatomic. So that means that you're going to name your metal normally, and then you're going to use the name from the polyatomic chart on the back of your periodic table for the second name. So an example of that would be calcium sulfate here. So we take the name of calcium, just comes straight from our periodic table, and then we see that we've got this big group here. So go look on the back of your periodic table to find what SO4 is, and then we see that it's sulfate. So that would be calcium sulfate. So if we go back up to the top, if we have two elements, then we have to ask ourselves a second question. Is the metal found on the back of the periodic table? So in your multivalent chart on the back of your periodic table, you're going to look for the metal there. If you don't see it on there, then you just have a normal ionic compound. So for that, you just need to write the name of the metal first and then change the ending of the non-metal to "ide." So if we have CaCl2, you're going to look on the back of your chart and see if Ca is in there. You'll see that it isn't, so we just name this normally. This is just calcium chloride. If the metal is found on that chart on the back of your sheet, then you have a multivalent compound. So for that one, you have to be able to say which version of the multivalent metal it is that you're talking about. So this is where we use the backwards crisscross to find what the charge on the metal would be, and then you write that charge as Roman numerals in the name. And then the second part is the same as normal. We're going to change the ending of the non-metal to "ide." So for example, if we have Fe2O3, we're going to backwards crisscross, so this 3 would really come up here to the iron, and this 2 would go over as a -2 on the oxygen. So this would be iron 3 oxide, and that 3 represents that the charge on our iron is +3. So that's if we're trying to name a compound. One thing to be careful of is that compounds can be polyatomic and multivalent at the same time. So we could have, say, iron and sulfate together. So you would still have to use Roman numerals, and you'd still have to use the name of the polyatomic from your chart on the back of your periodic table. So just be careful of that, is that it is possible to have both polyatomic and multivalent at the same time. If we're going backwards, so if you have the name and you need to write the chemical formula, first question you're going to ask is, does the second element name end in "ide"? So we're looking for that IDE. If it doesn't end in "ide", if it ends in something else other than "ide", you have a polyatomic. So what you'll want to do is you'll want to crisscross the charge of your metal, which is just found normally on the periodic table by group number, and you're crisscrossing that with the charge on the polyatomic. So you have to use the back of your periodic table for this. You'll be able to see in that list the different types of polyatomics and the charge on them. So that's the charge you're going to crisscross. And so as we crisscross that, if the number of polyatomics is greater than 1, then we need to put in brackets. So this is where things can get a little bit confusing. So if we have aluminum bisulfate, the first thing you should notice is that our ending is not "ide", we ended in 8. So this is a polyatomic. I know I'm going to have to use the back of my periodic table for this. And let's write the charges. So aluminum is in group 13, meaning that it has a charge of positive 3. And bisulfate, we find on the back of our periodic table, has a charge of negative 1. If we were to crisscross those, the 1 would come down to aluminum, which we don't need to write. You don't need to write a 1. But the 3 would come down to the bisulfate. And so because that number is greater than 1 there, we have to put bisulfate in brackets and put the 3 outside the brackets. So we end up with Al brackets HSO4 brackets 3. If your ending does end in "ide," so let's go up here and go the other way. The second question you need to ask is, are there Roman numerals in the name? If there's not, it's just a normal ionic compound. So just like normal, you're going to crisscross the charges from the metal and the nonmetal to find the subscripts, to find those little numbers. So if we have magnesium on the chart, on our periodic table, we'd figure out that it's a positive 2. Phosphorus has a charge of negative 3, and so we crisscross those and get Mg3p2. If there are Roman numerals, that is signifying that we have a multivalent compound. So if that's the case, we need to crisscross the charge of the multivalent metal, which is nice and easy because the Roman numerals tell us what that charge is, and we're crossing that with the charge of the nonmetal that we find on the periodic table. So if we have lead 3 fluoride, that Roman numeral there, that 3, is telling us that the charge on lead is positive 3. And then fluorine, we would look on our periodic table and figure out that that has a charge of negative 1. And then when we crisscross those, we'd end up with PbF3. So I hope this flowchart helps you kind of as you go through these questions. If you were confused with the sheet on Friday, I would use this chart to try to help figure things out. But if you have any further questions, always let me know. Have a great day.